Hello, this is David Green from NASA Earth Science, Disaster Risk Reduction and Resilience Program. It has been quite a year. One of the things we learned that there is very little natural about disasters. Making space for disasters means recognizing that disasters are a social issue. It is the change and the interplay between our natural world, our human ecosystem, our economies. And this systemic disaster risk can be managed, but it takes an Earth systems view to put the pieces together. But it also requires situational awareness, the information and the knowledge needed in the right place at the right time, with people who can understand how to plan, to use that information to have the confidence in their choices and decisions, to act when they can proactively anticipate what is going to happen and intervene in the best way forward. Looking at the hazard alone is not enough. Exposure of infrastructure and communities, the vulnerability of people and our biodiversity and ecosystems, our ability to cope and use that information to mitigate and adapt are the collective information that is needed and can be gathered from Earth observations and our system. Therefore, we can map this information, but we need to think of this in a multi-hazard approach from well before an event to mitigate and prepare, to understand that during an event, near real-time information and near real-time science does come into play, and it informs the next steps of effective and lasting response and sustainable recovery. Enabling the analysis across space and time means that all of the disciplines that we bring together at a geophysical science meeting means looking across the river basins, the earthquakes and the volcano areas, those tropical storms and droughts, from inland to coasts to the peaks of our mountains. Our entire fleet of observations, flight, on the ground, our satellite, and even our space station, everything must be used effectively in an interactive and smart strategy. Monitoring the Earth means monitoring the changes that interplay with vulnerability and exposure. It also must scale from a global scope to the scale of decisions. This means promoting the access to observations and making them useful, usable, to inform, to support, and guide. This means that we can reduce risk. The priorities are to engage not only fellow scientists, but all levels and manners of society on a global scale to partner to build science research results into applications that support the guidance in those areas that do accumulate and tend to cluster these areas of focused risk. That information must be exchanged in a way that it can be connected and interacted. The NASA Disasters Program embraces a geospatial portal approach where we layer information and enable the analysis, understand and interpret. If you think back to the very beginning of 2020, one of the first events of the year was the Puerto Rico earthquake, shattering and disrupting the infrastructure of municipalities and communities. Radar satellites and in situ measurements provided the tools to understand the scope and scale and the information to guide recovery. But it was also a year of fires. Australian wildfires scorching that continent, soon after sweeping across South America, and fires most recently in California, Oregon, Washington, Colorado. Our scientists and partners, from airborne UAV SAR to a collection of other airborne instruments, remote sensing satellites, models, maps, and tools, brought that information together to inform how to manage and are now preparing for the next steps. While other parts of the world were struck by typhoons, hurricanes, and monsoons, the super cyclone Amphan reminding us here that this was a year of COVID, and evacuations must be done in a way that is different and requires and can be complemented by the type of information and maps of damage and guidance to where is it safe to shelter and recover. Not all disasters are driven by a natural event. We have seen the explosions in Beirut this year, but many of the same tools, our remote sensing instruments, our monitors, our sensors, our tools and maps, helped partners understand what the situation was and how it evolved. When we look at the Earth from our day-night imagery, it reminds us of we have networks of communities lit up at night, but also disconnected when exposed to the threats of hurricanes, floods, tsunamis, typhoons. And if fragile and vulnerable, will indeed, the lights will go off. Our portal tends to put these story maps together with different types of imagery analysis and dashboards that collect flood information, helps communities understand routine as well as seasonal and often impacts on transport, economies, agriculture, and what we refer to as lifelines. When communities are disrupted, it often takes the shape of displacement of communities, settlements, and shelters that often find themselves in areas of increased exposure to a flood, a landslide, an economic hardship. Our tools were used this year to look at some of these in Bangladesh and other refugee nations. But this early information can be brought to our communities for planning, and then the monitoring and the mitigation to promote resilience. Certainly, COVID reminded us of how compounded are those interactions, from health to natural environment to the choices that we make in society and how they come together. And our Earth observations, our science, informs risk-based decision-making. We are partners. Scientists are trusted partners, helping communities stay connected. NASA's disasters program takes an Earth systems approach. We thank you for your partnership. Together, we indeed can make the Earth a safer, more viable, resilient, and sustainable community. Thank you.